main script to load any table in ETL pipeline. I am sure if you're working in ETL, you are creating these scripts on day-to-day basis.
And you see 9 rows are inserted. So what we will do is we'll check this table to see whether the data for 24th February is loaded or not. So let me run this query end to end and see the output. So you see here.
In this video, I'll explain you what are the four different types of scripts you must create for any EDW table in ETL pipeline. If you want to up your ETL game, this video is for you. In any ETL pipeline, we'll have different sources sending data into staging layer. The staging layer will load that data and will be used to load our EDW table. We are going to focus on this layer as part of this video. So let's see what are the four different types of scripts you must create for any table in ETL pipeline. The first one is the incremental script. It is generally a daily job. So this is the main script to load any table in ETL pipeline. I am sure if you're working in ETL, you are creating these scripts on day-to-day basis. The incremental script loads the incremental data to the target table at chosen frequency. Mostly it is daily job, but it can be intraday, like running multiple times in a day. It can be weekly, monthly job as well. In some cases, I've also seen quarterly, half yearly, and annual jobs. It runs quickly and has SLA tied to it. So incremental jobs runs on daily basis. It brings in the data, loads the fact table, and then there are reports on top of it. So generally, there are some SLA tied to the incremental job. Like so, say you have to complete your job before 5 a.m. every day because after that the business users will come online and they want to see the new data. The next type of script you must create for any table is the backfill script. These are generally the ad hoc jobs. These are used to fix data issues. So say you have a table and you realize that, okay, 2 months back, whatever data you have loaded into that table is not right. It could be issue with the source has fixed from their side and now you have to fix that data in your target table as well. At such situation, the backfill scripts come into the picture. You move bulk of data from the source into the target table. It runs on ad hoc basis as per the need. It can refresh weekly, monthly, yearly, or even fully refresh the table. It runs for longer time as it handles more volume of data compared to incremental script. The third type of script is validation script. So for every table, you should have a validation script also. What it does is it's part of a audit balance control, which is a concept tied very closely with ETL. So an audit script is used to compare target data with the source data. It aggregates and compares measures between source and target. It runs on daily basis after the incremental load, and it can be used to check possible values also. By that I mean you can also specify some specific values for any given column, and if the values are not in the listed values, then you can tag it as a validation failure. Validation script generally runs quickly if it is tied to an incremental job. The fourth kind of script is cleanup script. So you should also have a cleanup script tied to your target table in data warehouse. These are ad hoc and it can be a daily job also. So the purge script is used to delete data beyond the retention period. So say you have a retention clause of 5 years. It is like in data warehouse, you will only store 5 years of data. If any data is going beyond that period, you will delete that data because it is not in your retention policy. So retention period basically means that you have some compliance or some audit requirement for which you have to retain data for the last 5 years only. And you are not using that data for reporting purpose also beyond 5 years. So why to keep that data in your data warehouse? It takes storage, it sometimes slows the queries also because the table volume grows. So you can use a cleanup script to delete the data which is beyond 5 years of period. So depending on your retention period, you can schedule this job to run and delete the data. It can also delete data as per GDPR and other data regulations, right to be forgotten, etc. So in recent years, lot of data related regulations have come into the picture also, where a user can come and ask the company to physically delete all the data they have about that customer. And company has to abide by that. They cannot store the customer data if the customer is not giving them permission. Or if the customer is asking them to delete data, they have to delete it. else there can be penalty on them. Cleanup script generally runs on daily basis. It can also run on ad hoc basis and are generally used to delete old data. It runs quickly and generally are scheduled to run in non-peak hours, maybe during midnight hours when not many jobs are running. Incremental script main condition while implementing logic is you extract the data from the source which is greater than the last loaded time frame. Then you join it on the basis of primary key and the time which is greater than already loaded data in target table, and then you load it into the target table. This will become more clear when we'll do SQL hands-on later in this video. So the main conditions are you will apply some condition on a time frame to extract data from the source into staging table, and then staging will do a join with the target table to see what data is already present and what is new, and then you will load only the new data into the target table. The second type of script we discussed was the backfill script. The main condition for implementing backfill script is you have to extract data between the required time period, then delete the data for that time period from the target table and load it from the source. Backfill, we generally don't run for a 1 day data or a 2 day data. We run backfill for a big time period, say 1 month or 2 months or maybe a year of data from the source into the target table. The validation script, it calculates the count or sum of numerical columns in source and target, and then it just compares it. And if the comparison fails, then it highlights for which time period the comparison has failed. You can run your backfill scripts to fix the data issue. And the cleanup script generally runs the delete, which is greater than the retention period. So if this is a little bit clear to you, let's switch to the SQL hands-on. We'll write SQL queries to implement these scripts and we'll see how easy or how difficult it is. Let's start with the SQL now. So what I have done is I have already created the environment. The environment consists of three tables, one corresponding to the staging area, the other corresponding to the EDW, and the first one corresponding to the OLTP. So the basic flow is from OLTP table, I will load my staging table, and from staging table, I'll apply some transformations, business rules, and I'll load my EDW table. For the sake of simplicity, right now I have kept straightforward movement of data from OLTP to staging, staging to EW. We'll apply some basic rules only, not complex business transformation rules, but a basic rules to demonstrate how an incremental script works, how a validation script works, how a backfill and a cleanup script works in production environment. So we'll start with the incremental script first, then we'll create a validation script, we'll create a backfill script, and we'll create a cleanup script, right? These four scripts we'll create as part of this video. I'll also show you some data, what I already have. So in OLTP, I can see I have some data. The staging table always runs in truncate load mode. So right now the staging table is empty. And I also have some data in my EW table, right? Now, my idea is that today, say, date is 25th February and it's a daily job. So I'll just write down these things. It's a daily job. Date is 25th February 2024. So my incremental job will run for 24th February 2024, right? Because by incremental, it's a daily job. So on 25th, it will load the data for 24th February, 1 day prior, right? So if you have seen my previous videos, you already know how the incremental jobs run. So as part of incremental script, what I will do is I will load my staging table first. So staging table, as I said, always runs in a truncate load mode. So we'll create a delete statement for my staging table. The next statement is insert into staging sales. And now this will get data from my OLTP, right? So OLTP sales, where, and if it is an intraday job, maybe I'll keep my sales time column as a time only. But now since I'm running a daily job, I have a flexibility to convert timestamp into date and apply all operations on that date column. So what I will do is I will just convert the sales time column as date.
So what I will do now is I have to load data for 24th February and today is 25th February. So I will get 25th February as input parameter from my scheduler, which is Airflow, Tivoli, Control M, anything. So I'll use that parameter here, which is basically my execution date. And then I have to run data for previous day. So I'll do minus interval 1 day. And this will be my staging data, right? So I'll just run this query and see the output. So you see here, I'm getting data for the 24th February. And this data will come into my staging table. So I'll load my staging table from this query. So my staging table is loaded, right? If you want, I can show you the data also in my staging table. So you see, entire 24th February data has come into my staging table. The next step from OLTP to staging, we are done. The next step is to load EDW table from my staging table. So I can directly load my EDW table also from my staging table because we have already done a check. But in most of the cases, right, it's good to have an extra layer of protection while loading data into my final table, right? So I'll just do a delete from EDW sales, and I will use staging table. Now what I'm going to do here is I'm going to make sure that whatever data I'm going to load into my target table, that data is either new or it does not exist into the table, right? So what I will do here is delete using state sales, where state sales dot sales ID equal to EDW underscore sales dot sales ID. So sales ID say it is a primary key. So I'm just checking that if that primary key already exists in my table, then I should delete it. And to further strengthen this rule, what I will do is I'll also add a time factor to it. So sales stage sales dot sales time equal to EDW sales dot sales time, right? And I will just make sure that whatever data I'm getting from my staging table, it is more recent than what I already have in my EDW table. So I'll just run this script. So you see, it does not delete any data because right now in my EDW table, I did not have any data for 24th of February. The last loaded data was for 23rd February. So it did not delete anything, right? At this step, maybe it is required. It's a good way to avoid duplication happening into your target table, right? So the next step is to load this table. So I'll just load this table, select, and I will do T1 star from state sales T1. Now this query in itself should be sufficient in most of the cases. But again, we in production, we add extra layer of check to avoid any duplicate. So I'll do left join with my EDW sales, which is my target table, right? And my idea here is, again, I will do a similar join on T1.sales ID equal to add T1's on sales side. I can use this, right? And what I will do is I will say that EDW underscore sales dot sales ID is null. So now what I have done is I will use T1 here, the alias name. I'll use T2 here, the alias name, and I will use T2 here. So what I am doing is I'm doing a left outer join with my target table and making sure that I'm going to load only those IDs which does not exist into my target table, right? So I'll just run this SQL query. And you see 9 rows are inserted. So what we will do is we'll check this table to see whether the data for 24th February is loaded or not. So I'll just come down. Let me close this. And I can see the data for 24th February is also loaded into the table. So we are good. So this is a typical incremental script. You can put it in a SQL file and run it on daily basis. There can be more business rules and there can be some specific use cases where you may not want to use this approach. You just want to dump everything. This should be sufficient for you. Or it could be that you want to include more columns here in the join and everything. But at a very high level, at a very basic level, this is your incremental script, right? So if this is clear, let's go to the validation script. So validation script, as I said earlier, you use this validation script to identify some data issues. Now that data issue could be that your incremental job failed for a day, say for 23rd, 21st, 20 February, 3 days the job failed, and then 24, 25, it ran successfully. So you are missing a data for 21st, 22nd, 23rd February in your table, right? And this validation script actually comes into picture when it tells you that, yes, there are some data in your table which are missing. And how do we identify? We identify it by comparing our source data with our target data, right? So in this case, the staging table will not play any role. We'll compare our OLTP table with EDW table to find out if there are any missing records. So let me start with creating a CTE first, and let's call it OLTP val as, and then what we will do is, and validation, we don't compare column by column, row by row. To speed up the process, what we do is, as I said earlier, we calculate the measure, right? So I see sales amount as the measurable column, which I can use to calculate some measure. So what we'll do for every store, for every date, what was the total sales amount? And that amount we'll compare in our target environment also. And if it is matching, we are good. If it is not matching, it means some rows are missing. So we'll see what we'll do now is select store ID, comma. Again, I will just cast the timestamp column into date for the sake of simplicity. And in this case, we have that flexibility also to do it. So I'll just give it a name as sales date. And then what I will do is I'll do sum of sales amount as total sales from OLTP sales, where now say I want to do this check for January 2024 data, right? All the data for January 2024, I want to run validation for this. In a typical scenario, you may run it like we have loaded data here for 2024 0 to 24 date. So maybe for 24th February only you will run the validation. But in this case, for sake of simplicity, I want you to understand that we are going to run a validation script for an entire month of January 2024. So what it will be, again, I will just cast my timestamp column as date, and then I will specify, the condition between 2024 01 and 2024 01 31. So this completes my entire January 24, and I'll just do group by 1, 2. So this becomes my CTE for OLTP. Similarly, I'll create the same logic. I'll use it to create a CTE for my EDW also. So I'll just copy paste the code and I will change the table name here, right? And I don't think I have to do any more changes. This should be good enough. So now I have two CTs, one with OLTP data, one with EDW data. All I have to do is just compare now. So I will do T1 dot store ID, T1 dot sales date, T1 dot total sales, and T2 dot total sales. If I want, I can give it the alias name also as OLTP sales, and this as EDW sales. And then I can just compare it, right? Whether the values for the sales are matching or not. So I'll use a case statement here, case when T1 dot total sales not equal to T2 dot total sales. We say it, then we say it is a not match. Else, if it is matching, then we'll say else match. And we end our case statement. Let's call it as a validation result from, and then we will use our CTE OLTP as T1, and we do a left outer join. We don't have to do inner join here because inner join will only check for the rows which are present in both the tables. We don't want that. We want all the data from the source, whether it is present in target or not. So left outer join will work here, and we will do store ID equal to T2 dot store ID and T1 dot and T1 dot sales date equal to T2 dot sales date. So this is my query. I'll take Take 2-second pause here and see if this query looks good to you or not. Let me run this query part by part first and then show you the output. Okay. So if I just run this, you see the output. It has the store ID, the date ID, and the total sales. Store ID, date ID, and the total sales. So for every day, for every store, I have what is the total sales amount in my source. And same data for January 2024, I have for my target table as well. So store ID, date ID, and total sales. And then I'm just doing a comparison. So let me run this query end to end and see the output. So you see here, I can see that for 20th January 101 store ID, there is a not match. Then 102 21st, there is a not match. For 202 20 January, there is a not match, right? So I do see there are some dates, and for some store IDs, there is a mismatch between the data of the source and target. It means data completeness and data accuracy in my EDW table is not complete, right? It's not correct. So I have to do something to fix this data. Now the validation script has done its role. It is supposed to tell me if there is any mismatch in the table data, and it has done that. Now my next step is to fix this data issue. Now to fix the data issue, I have two options. Either if it is of a recent date, I can run incremental script. So say instead of January, if it was February, and 2-3 days back only data issue has happened. So I'll run my incremental script for the last 2-3 days and I'll cover it. But what if the data is for the last 6 months? Then I'm not going to run my incremental job for the last 6 months. It will take me days and weeks to cover up, right? To do the catch up. In this case, we'll run the backfill script. And as I said earlier, backfill script is generally used to dump the data from the source into your target table to fix the data issues. So let's start with the backfill script first. We'll use something similar to what we have in incremental. So in incremental, we delete and load our staging table. So I'll just copy and paste it here. But in this case, I'm not going to load. We identify data issue with the January data, right? So I'm not going to load the data only for 24th February. I am going to load data for entire January from my source into my staging table. So this will become 01. This is also 01. And instead of interval 1 day, it will become and cast 2024 01 31 as date. So now I have data for the entire January period loaded into my staging table. So let me run delete first. I will run my insert statement now. So you see 50 rows for the entire January, all the data from stage OLTP is loaded into staging table. I'll run this query and show it to you. You see all the data for January is loaded into staging table. So if this is clear, we'll just load our EDW table using this staging table. And the logic is also very straightforward. Delete from EDW sales and logic will be this. Now I have entire January data, right? I don't have to compare with my primary key column where the primary key exists or not and then delete it. I'm bringing entire January data. So blindly what I will do is, it is safe to do in this case with very less risk because I'm getting entire data for January from the source. I will delete everything from my target table where it is between 1st of January till 31st January. So let me just run this query and delete the data. So my data is gone. And the next step is once the data is gone, I have to load the data back from my staging table, right? So what I will do is select star from stage sales. That's it. I don't have to apply any more checks because stage sales has the entire January data and I have to load it. So let me run this query. I see 50 rows loaded. Let me go above and show you how my EDW tables look like. So EDW table has a lot of data in it. Now what I can do is after running the backfill to confirm whether it has fixed the problem or not, I'll run the validation script again. And this time in validation script, I see there are no mismatches. All the mismatches are gone. So it means my January 24 data is fixed after running the backfill and I can proceed with my usual incremental load on daily basis, right? I hope this is clear to you and this is also making some sense. And this is the basic scenario, how we create the backfill script, how we create the validation script, how we create the incremental script, how these scripts work together to make sure that whatever data you are loading is correct. And now let's quickly create a cleanup script also. So cleanup script, as I said, it is used to delete data which is going beyond our retention period, or to comply with some data regulations like GDPR. And almost now every country, every big country has, even India has their own data regulations, right? So we'll simply run a delete statement, and then let's convert the sales time. And in this case, let's assume we want to delete data which is older than 5 years, right? So any data which is older than 5 years, we will just delete it. So today date is 2024-02-25. This is coming from my scheduler. So it may look like it is hard coded, but in actual production scenario, it will be a parameter, and this parameter gets the execution date from your scheduling or the orchestration tool, and minus interval 5 year, right? And before I run this delete, right, let me run a select statement to show you that if there was any data which was older than 5 years, so that delete makes more sense to you. So if I run this, I see yes. So there were 7 records which are from 2016 and 2017 into my EDW table. So what I will do is I will just run this delete statement, and every day this delete statement can run, because this value will also increment by 1 day, and any data which is beyond 5 years of retention period will be deleted. So if I run this, 7 rows are deleted, right? So this is all I wanted to cover as part of the SQL and this video. All the SQL I have used, even the setup of the tables and the queries I have used here, I will put it in the description box below so you can copy and practice it yourself. But at a high level, this is all I wanted to cover, that for any ETL table, especially the EDW table, there are 4 kinds of script you must create: the incremental script, the validation script, the backfill script, and the cleanups. There can be more types of scripts also, like you may want to create a full refresh script every time blindly, no filters. It will simply truncate the table, load everything from the source. Or there can be some other validation scripts also. But at the high level, make sure whenever you are creating a ETL table, you are loading it from staging, make sure that there are 4 kinds of scripts for each EDW table. By exhibiting this knowledge, it shows that you understand ETL very well. So this will help you in cracking some ETL interviews as well as in your day-to-day ETL job also. You can exhibit these knowledge. You can exhibit this knowledge to up your ETL game. Thanks for watching this video. If you like this, do remember to like the video and subscribe if you are new to the channel. Thank you.